welcome back to RamZland. Today I want to show you the photochemical reaction of an equal ratio of hydrogen and chlorine gas versus a violet laser. Check this out.
So to demonstrate this reaction, we're going to use a tray of water, test tube with stopper, 1000 milliliter filter flask, PVC pipe, rubber stopper. These are two copper-plated carbon electrodes that are used for arc welding, DC power supply, a green laser for comparison, a UVA violet laser to prompt the reaction. The first step is to prepare your electrolysis vessel. So I filled this 1000 milliliter filter flask with 12 molar hydrochloric acid, and I'm leaving about an inch of space here at the top for hydrogen and chlorine gas to flow through this PVC pipe. The second step is to prepare your test tube by submersing it in your tray of water, get all the bubbles out, and then lead your PVC tube into your test tube. Okay, so your basic setup looks like this. There should be only water in your test tube. That way, when you electrolyze your hydrochloric acid, the chlorine and hydrogen will flow through the tube and displace water in your test tube, so the test tube becomes filled with an equal portion of hydrogen and chlorine gas. Next, connect your DC power supply to your electrodes and turn on your DC power supply. When it looks like chlorine and hydrogen gas have filled your test tube, I would invert it just to get any last bubbles out. And then take a stopper, put it in the water, and as you take out the tube, you're going to put that rubber stopper in. But again, you don't want any air to get in there. You want it to all be hydrogen and chlorine gas. I'm going to wait, get a few more bubbles in there. It looks good. Okay, now I'm going to put the cap on while it's underwater. So I have a good test tube that's filled with my gas mixture.
Okay, now you're ready to attach your test tube to your ring stand and to test the gas to see which wavelength of light will cause a reaction. So this first wavelength of light is a green laser. This doesn't have enough energy to cause that photochemical reaction between the hydrogen and the chlorine gas. But the minute I hit it with this violet laser, which has a shorter wavelength, meaning it has more energy, it will cause that stopper to shoot off the test tube. It'll create an exothermic reaction where you have a lot of thermal expansion in the test tube, and it'll make a loud bang. So get ready, here we go. Oh, that was loud. It shocks me every time I do this.
Here's the balanced equation for this amazing synthesis reaction. We start with reactants of hydrogen gas and chlorine gas. We have 1 mole of the diatomic molecule of hydrogen, that's H2, and 1 mole of chlorine, that's Cl. When those combine, it creates the product hydrogen chloride gas. We have 2 moles of hydrogen chloride, that's the 2HCl. But this is also a photochemical chain reaction. If you remember, we started with an equal ratio of hydrogen and chlorine gas. And the reason for that is because both hydrogen and chlorine are diatomic. That means that they always travel in pairs. So when we hit the test tube with the UV violet laser, it has a short enough wavelength and enough energy to break apart the diatomic molecule of chlorine, creating a free radical of chlorine, which then bonds with hydrogen to make hydrogen chloride. But when it bonds with hydrogen, it creates a free radical of hydrogen by breaking apart the diatomic molecule of hydrogen, and the chain reaction continues in this amazing reaction.
I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.